Hello everyone. Welcome to the mini lecture on electromechanical control technology. Today, we will learn about debugging of servo motors. Our lesson will cover the following topics. Through this lesson, I hope you can correctly initialize parameters according to the user manual of the servo motor and control card, including control mode, key ID parameters, enable signal, etc. You should also be able to accurately connect the signal lines between the servo motor and control card to ensure that the motor can start normally and respond to control signals. You should be able to independently complete the closed-loop control debugging of the servo motor, including enabling the servo enable signal through the control card, testing whether the motor's rotation direction is correct, suppressing zero drift, and adjusting closed-loop control parameters to ensure that the motor can move accurately according to the control card's instructions. Before debugging the servo motor, it's important to understand the basic principles and characteristics of the servo motor. A servo motor is a high-precision, high-response speed motor widely used in automated equipment, robots, CNC machine tools, and other fields. A servo motor typically consists of the motor body, encoder, and driver. Its working principle is to use the encoder to feed back the actual position and speed information of the motor, and the driver adjusts according to the control signals, achieving precise control of the motor. Next, we will specifically learn the steps for debugging the servo motor. 1. Parameter initialization. Before making connections, initialize the parameters. On the control card, select the appropriate control mode. Set the PID parameters to 0. Ensure that the default enable signal is turned off when the control card powers on. Save this state to ensure that the control card starts in this state again when powered on. On the servo motor, set the control mode. Configure the enable signal to be controlled externally. Set the gear ratio for the encoder signal output. Set the relationship between the control signal and the motor speed. Generally, it is recommended that the maximum design speed of the servo during operation corresponds to a control voltage of 9 volts. 2. Wiring. Power off the control card and connect the signal lines between the control card and the servo. The following wires must be connected: the analog output wire from the control card, the enable signal wire, and the encoder signal output wire from the servo. After verifying that the wiring is correct, power on the servo motor and the control card, as well as the PC. At this point, the motor should not move, and should be able to be easily turned with external force. If this is not the case, check the settings and wiring of the enable signal. Turn the motor with external force to check whether the control card can correctly detect changes in the motor's position. Otherwise, check the wiring and settings of the encoder signal. 3. Testing direction. In a closed-loop control system, if the direction of the feedback signal is incorrect, the consequences can be disastrous. Enable the servo signal through the control card. The servo should rotate at a relatively low speed. This is the so-called zero drift. There are usually commands or parameters on the control card to suppress zero drift. Use this command or parameter to see if the motor speed and direction can be controlled through it. If it cannot be controlled, check the analog wiring and the parameter settings of the control mode. Ensure that a positive value makes the motor rotate forward and the encoder counts increase. A negative value makes the motor rotate in reverse and the encoder counts decrease. If the motor has a load and limited travel, do not use this method. Do not apply excessive voltage during testing. It is recommended to stay below 1 volts. If the directions are inconsistent, you can modify the parameters on the control card or the motor to make them consistent. 4. Suppressing zero drift. During closed-loop control, the presence of zero drift can have a certain impact on control effectiveness, so it's best to suppress it. Use the parameters on the control card or servo to suppress zero drift, and carefully adjust it so that the motor speed approaches zero. Since zero drift has a certain degree of randomness, it is not necessary to require the motor speed to be absolutely zero. 5. Establishing closed-loop control. Once again, enable the servo signal through the control card and input a relatively small proportional gain. As for what is considered small, it can only be a matter of feeling. If you're really unsure, input the smallest value allowed by the control card. Turn on the enable signals for both the control card and the servo. At this point, the motor should be able to perform actions according to the motion commands. 6. Adjusting closed-loop parameters. Fine-tune the control parameters to ensure the motor moves according to the instructions from the control card. This is a necessary task, and much of this work relies on experience, so we will gloss over it here. The debugging of servo motors is a systematic and complex process that requires an in-depth understanding of the basic principles and characteristics of servo motors, as well as practical experience. Through this course, I hope you can master the core skills of servo motor debugging, laying a solid foundation for your future work. Lastly, please think about this lesson and complete the following exercises to consolidate today's knowledge points and deepen your understanding. That concludes our lesson for today. See you in the next lesson.